Hey there, guys. In this next series of videos, I want to show you guys how to create a really simple animated game using JavaFX. So you see the game that I've brought up on screen here. If I start playing the game, it's just a straightforward, okay, balls bouncing up and down, and I can control the soccer shoe with my arrow keys. And the goal of the game is to keep the ball from falling past the bottom of the screen. If I let it go this time, it falls past, game over, and I'm back to my start screen. So the first thing to do is to come up with a little bit of plan about this program and think about some of the things that we are going to need to keep in mind and some of the design principles that we're going to need to use in order to make this. Okay, so I've just mocked up my screen here in Google Slides to think about this program a little bit, and three things that I really want to keep in mind and design into the code while I'm writing this game. So first thing is that this game has two different states that the game could be in while the program's running. Either you could be looking at the title screen, which looks like this. It has the title and that tells me that I press space to play, and it's got the other objects on the screen. Or you could be in the state when you're actually playing the game where things are moving around on the screen and it doesn't have the title anymore. So, like, that part disappears, right? So, I have my playing the game state and I have my title screen state. And I want the program to behave a little bit differently depending on what state the game is in. I want things to be animated when it's in the playing the game state, and I want things to be fairly static on the screen when it's in the title screen state. And I want different things appearing on the screen. So that's going to be one design consideration. Two different states that my program could be in. And how do I encode represent that I have my game in either the title screen state or the playing state, and how do I get my game to respond differently depending on the two different states that it's in. So that's one of the focuses that we're going to have in creating these animated games. How do we create the different states? Because a game needs that, right? Like, it needs a startup screen, and it needs a this is what the screen is like when you're playing the game. Once the game's over, you could even imagine doing 3 to 4 different states where, okay, you got to the end of the game and now do you get to see a high score list? That might be another game state. Um, some games might have, like, at one point you're at the store buying potions and magic spells and whatever else, and in another state you're wandering through the wilderness killing all the monsters that are attacking the town. I don't know, I'm just making that up, but you can imagine that there, depending on the complexity of the game, multiple different states that the game could be in. Well, how can we create that within our code? That's the first thing I want to think about. Now, once we get playing the game, in order to actually have something be animated, let's think about a little bit what has to happen to make that animation look nice. On the screen right now, I have my two images, right? I have the boot and I have the soccer ball. Now, just consider the soccer ball for a second. In the game, what you want to see is the soccer ball kind of moving around nicely. I guess I can't really do it on slides, but just kind of moving in a nice arc across the screen. How do I make that happen in code? I use the word animation very specifically because in code, basically what I want to do is do the computations to move the soccer ball a little distance, redraw my screen, and then do the computations to move the soccer ball a little distance again and redraw my screen. Do the computations to move the soccer ball a little bit again and redraw my screen. And keep repeating that process in order to get the ball to look like it's moving. I just have to keep repeating that over and over and over again really quickly in order to get that ball to look like it's moving. Code-wise, that sounds very tempting to say what we'll do is we'll make a loop. We will do the computations, draw the screen, do the computations, draw the screen. And in some respects, that's exactly what I want to do. But JavaFX is an event-driven programming style, right? Think about all the other programs that we've written throughout the quadmester where the program responds when you click on a button, when you press the mouse button down, when you type a key. An event occurs, and then JavaFX informs your program, okay, something has happened, respond to that event now. So we need to design a way that there will automatically be an event occurring basically as frequently as possible. And when that event occurs, what do we have to do? We have to make the calculations to move the soccer ball a certain distance, just a small distance, because we're hoping that these events happen very, very quickly, and then redraw the screen. Then we just wait for the next automatic event. We need events that don't require user input in order to be triggered. So we're going to be using an animation timer in order to trigger automatic events as quickly as possible. And the animation timer in JavaFX is very fast. It can trigger 150, 200 events per second, just depending on how in-depth the calculation that you need to make is. And the calculations we need to make are not that in-depth. So we can get pretty smooth animation for this soccer ball just by having JavaFX trigger automatic events for us. But we need to set that up. When an event occurs, move the ball. When the next event occurs, move the ball. But we don't want those events to be user interaction events. We want those events to be automatic things. And the third thing to think about is the shoe itself. Now, I said earlier that the shoe moves when I hold down my arrow keys. And that's an important piece to think about as well. I want the shoe to be moving as long as I'm holding down the arrow key. Again, what's the event that's happening there? There's an event that happens when you press a key, and there's an event that happens when you release a key. But holding the key doesn't create a whole series of events to like, oh, the arrow's down, move the shoe. Oh, the arrow's down, move the shoe. Oh, the arrow's down, move the shoe. So we need to tie the shoe movement into our automatic events. And essentially what we need to do is every time we move the soccer ball moves, check to see if an arrow is being held down or not. And if it is, also move the shoe. All right, next time the soccer ball moves, if the arrow key is held, move the shoe. Next time the soccer ball moves, oh, the arrow key is not being held down, don't move the shoe. Next time the soccer ball moves, oh, the other arrow is being held down, move the shoe the other direction. So we're going to add that part to our calculation as well. Now, how are we going to be able to tell if a key is being held down when there's no events that happen, when a key is being held? What we're going to have to do is we're going to have to watch for that event that says the key was pressed, and then make a flag in our program that says that key is being held down right now, and watch for the event when the key is released, and then change the flag in our program to say that that key is not being held down now. And then every time we have the automatic update of the screen, we can just look at our flag and say, is the key pressed or not pressed currently, and decide what to do based on that. So just to recap that discussion, as you work through this series of tutorial videos, there's sort of three main game design patterns to watch for and understand how they're built into the Soccer Keep Ups game. The first design pattern is going to be game states. How do we manage the difference between being in the title screen state and being in the playing of the game state? The second main design pattern is the use of an animation timer, right? And the animation timer causes JavaFX to trigger events without user interactions, so automatic events. And during each one of those events, we're going to calculate the next frame for the game by making calculations that move all of the objects around on screen and then letting JavaFX redraw the screen for us. Right? And the third game design pattern to keep an eye out for is what I'm going to call keyboard polling. And what keyboard polling means is that our program's going to keep track of the state of the keys on the keyboard, whether they're being pressed down right now or not. Right? And then during each one of those animation timer frames, we're going to check our tracking of the state of the keys to see whether it's held down or not. And we're going to have the program respond based on what the user's input is on the keyboard for our keyboard polling. That's different than having a keyboard event, right? We're not going to trigger keyboard events and have the shoe move around because of an event on the keyboard. We're going to have the shoe move around using keyboard polling by tracking the state of the keys. And the reason that we do that is we get much smoother animation for our game by doing keyboard polling instead of using keyboard events. And also the user doesn't have to sit there going left, 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 left. They could just hold the left button down and not have to have the program have lots and lots of events the left button was pressed.